Correlation does not equal causation. You've probably heard that saying 1,000 times. However, correlational research is useful for exploring possible causes. Let's consider some examples from health research, where knowledge of causal factors of disease could save lives. Probably the most cited example of a link between stress and illness is this large correlational study, which you would never be able to do nowadays. Here's why. This was done at the Common Cold Unit, a research facility in England dedicated to finding a cure. Participants stayed at the facility for extended periods, allowing for measurement of loads of variables. In this study, 394 people completed the psychological stress index and were administered one of 5 respiratory viruses via nasal drops. The researchers waited and then measured infections by looking for the presence of antibodies in the blood, shown in the graph on the left, as well as percentage of participants who developed cold symptoms in the graph on the right. What should be clear is that the higher the levels of stress, the higher the percentage of infections and colds. Do we know if high stress caused these infections? That's one possibility, but another is that high-stressed individuals might be getting less sleep, and that could be the cause of the increased infections and colds. This study measured 2 variables in participants who had a diagnosis of major depression: the days of untreated depression on the x-axis on the bottom, and the size of the hippocampus on the y-axis on the left. If depression is untreated for a long time, it's linked with smaller hippocampal volume, as shown by the downward line. Does depression shrink the hippocampus? Or does a small hippocampus cause depression? There are 2 different problems that arise in correlational research that prevent causal conclusions. The first is the directionality problem. Let's start with an example from my own life. When I was very young, I needed glasses, and I had to sit close to the TV in order to be able to see anything. My relatives said the reason that she needs glasses is that she was sitting too close to the TV. But from my point of view, the reason that I needed glasses is because I couldn't see the TV. That's why I sat close. This isn't an experiment with hard data, but it does show that it's impossible with a correlation like this to determine causation. So the directionality problem with correlational research is that we can't tell what causes what. Another issue with inferring causation and correlation in correlational research is the third variable problem. Let's look at a correlation that's difficult to explain. The number of dogs in the city is positively correlated with the number of fire hydrants. Do dogs cause fire hydrants to be installed? Or is it that with loads of fire hydrants that people with dogs move to the city? Both of these seem incredibly unlikely. Is there another possible cause? Well, there is another variable that's associated with both of these, and that's population. In cities with greater populations, there are more dogs and more fire hydrants. So it's likely that this third variable is responsible for the relationship between the other 2. Test yourself. Identify one possible third variable that could explain the correlation between self-reported stress and colds, or untreated depression and hippocampal size. This is from Spurious Correlations, a website devoted to reporting kooky correlations. This one here shows solar power generated in Argentina and Google searches for "do vaccines work?" You can see a big jump in both measures in 2020. It's unlikely that the directionality problem is involved, since there's no evidence that searching Google for vaccine info affects solar power infrastructure in Argentina or vice versa. It's possible there's a third variable involved here, but it's also likely that if you measure enough variables, just by chance you'll find meaningless correlations. These can be quite strong. Notice the correlation coefficient. Here's another one. This time, solar power generated in Bulgaria compared to Google searches for causes of green poop. Again, notice the correlation coefficient. So how can we explore causation? For the reasons outlined so far, it doesn't seem like correlational designs are well suited to tell us about causation, there's too much uncertainty. However, correlational research does generate hypotheses that can be tested by other research strategies. One way to explore causation with correlations is to rule out possible causes using statistical analysis called multiple regression. The math involved is beyond the scope of this topic, but it involves measuring several independent variables and determining their influence on a dependent variable. Note that these terms are also used to describe variables in experimental designs, so it becomes confusing. So I'm going to call them predictor and outcome variables to avoid confusion. So how does this work? Let's look at some data from the World Value Survey on Subjective Well-Being, done in the early 1990s. It's been long known that income is positively correlated with happiness. Does money make us happy? The researchers attempted to address this question by controlling for income in their statistical analysis, holding it constant, and determining whether the relationship still exists. This table shows results for 1,000 people's ratings of life satisfaction and PPP, or purchasing power parity, which is related to the percentage of yearly income required to purchase a basket of goods in their home country. They found a relationship between life satisfaction and income and came up with a possible explanation, but wanted to see if they could hold income constant and see if the life satisfaction results changed. After controlling for income in less wealthier countries, the life satisfaction results were unchanged, suggesting that income was probably not responsible for happiness. So correlation does not equal causation, but it can still provide hints about possible causes, which can be followed up with research methods that do allow for causal explanations.